welcome back to my YouTube channel. Let's encode the logic. I hope you all are doing good. In today's session, we are going to discuss about operators. What are operators? Operators are the constructs that are used to manipulate the value of operands. We have seen so many operators like plus, minus, into, multiplication, and the division, and also equal to, and greater than, less than. All these are operators. These operators are used to manipulate the value of operands. See, 5 plus 3 comma 6 minus 7 comma a into b. Okay, let's see. So 5 plus 3 is an operation. Here plus is the operator and 5, 3 are operands. Similarly, 6 minus 7 is an operation which will give you the result of minus 1. 6 and 7 are operands and minus is the operator. Here a and b are operands. Into is the operators. So the operators are the construct that are used to manipulate the value of operands. So this plus is used to manipulate the value of operands. So if you do 5 plus 3, then some manipulation will happen and it will give you the result of 8, right? So that is what the use of operators. Now, Python support different types of operators which are as follows. So we have so many operators, as I said before, plus, minus, into, greater than, less than, greater than or equal to, many. And Python categorizes all these operators into subsets. So we have arithmetic operators, comparison and relational operators, assignment operators, logical operators, unary operators, bitwise, membership, and operators. Let's see all of them one by one. First one is arithmetic operators. We know plus, minus, multiplication, and division. In Python, in order to find a remainder, we use the modulus symbol, the percentile symbol, the modulus. And the next operator is double slash, which represents floor division. So there is a little bit of difference between this division and floor division. So this division operator always gives you a floating value. And whereas this floor division will gives you a precise value. And next one is exponent. So that was two star symbols denotes the exponent. For suppose if you want to compute the power of anything, like if you want to compute 2 square or 2 power 3, then you will use this 2 stars to compute the power. So let's execute them in ideally also. So let us take a equal to 30 and b equal to 50. Now let's do a plus b, which will gives you 80. A minus b gives you minus 20. A into b 1500. A divided by b. If you see this was the division. Now if you see, it was giving you the output in the floating point. Let's do b by a also. 1.66. Let us do b double slash by a. Let's do floor division. See, if you observe, this was given a precise value. Now let's change. Let us take c equal to 2 and d equal to 4 and do c power d. This means c power d. So 2 power 4, it was 16. 2 power 3, yeah, 8. So where here this a represents the base and this b represents the exponent. And next one is comparison operator. We know the comparison operators are greater than, less than, greater than equal to, less than or equal to, and also equal to. But in Python, for the comparison of any two operands, we will use double equal to, because equal to is mainly used to assign a value to a variable. So for that purpose, we are using a double equal to for the comparison. And if we want to check not equal to, this symbol is denotes not equal. Let's work on it also. Okay, now let's execute this comparison operators in the ideal shell also. Let us take a equal to some 10 and b equal to 20 and c equal to 10. Let us do a equal to b. It was false. And a equal to c. Since 10 equal to 10, it was true. And a not equal to b. Yeah, it was true. 10 is not equal to 20. It's given. And a is greater than b. Does 10 greater than 20? No, it was wrong. So it was given false. and A is less than B. Yes, it was true. 10 is less than 20. And B is greater than or equal to C. True. 20 is greater than or equal to 10. And B is less than or equal to C. It was false. Next one is assignment and in place or shortcut operators. Equal to. As I said before, this operation is used to assign a value. So B equal to A. The value of A will be stored in the variable B. And next plus equal to. This performs sum and assign value. See, if you use A plus equal to B, which means A equal to A plus B, the value of A plus B will be stored in this A. So it will do A plus B and that will be stored in the left operand. The value will be stored in the left operand. And minus equal to means it will do subtraction and assign the value. So A minus B value will be stored in the left operand A. Similarly, multiplication and also floor division also. Sorry, division and modulus division and the floor division also. So let's do that also. In previous arithmetic operator, we haven't worked on modulus operator, right? So let's do B mod DA first. So it will gives you 0. If we do the division of 20 by 10, then the remainder will be 0, right? Then let's do C mod B. It was 10. The remainder was 10. Yeah. Let's do this. Let us take some values like A equal to 5 and B equal to 3. Let us do A plus equal to B. Okay. Now see, what is A? It was 8, right? So if you see, 5 plus 3 equal to 8. Now 8 is assigned to the operand A. So when we print A, that has given me 8. And now A minus equal to B. Now let's see what is A. It was 5. A minus B. A is 8 and B is 3. 8 minus 3 is 5. That will be stored in the variable A. So when we print A, it was given me 5. I hope you get it. And A into equal to B. And if you do A, 5 into 3. A was 5 and B was 3. We did 5 into 3, 15, which will be stored in A. And let's do exponent form. Okay. A power of B. A power equal to B. Means 15 power 3. Let's do A. 15 power 3 is 3375. Similarly, you can do all these also. And next one is logical operators. In Python, we have AND or NOT operators. Before going into it, we need to know how this AND or NOT will work. Here, A, B are operands, and AND is the operator. The functionality of AND is both the operands should be true. Then only the output will be true. So, if you see T and T, it was T. Here B is false, so that's why the output is false. Here A is false, the output is false. Here both operands are false. That's why the output is false. And next one is A or B. The functionality of the OR is any one of the operand is true, then the final output will be true. Here all the operands should be true. Here any one of the operand should be true. Right? See, if you see T or T, both are true, so that's why output is true. And here A is true but B is false, but still one operand was true, that's why the output is true. Here B is true, that's why the output is true. Both are false, the output is false. Now coming to not B, the functionality of the not is if it is true, then the output will be false, and if it is false, then the output will be true. It will be reversed. So if you see, I did not B, so true will become false and false will become true. Here true will become false, false will become true. See, only one. And the condition of AND will be both the operand should be true. And the condition for OR is any one of the operand will be true. Okay. Let's try them. A equal to true. B equal to false. I was doing A and B. False. True and false, it will be false. A or B. It will give me true. I will do not A. It was false. True will become false. This is about logical operators. And the next one is unary operators. The unary operator acts on single operands. And the Python supports unary minus operator. Unary minus operator is different from the arithmetic operator. When an operand is preceded by a minus sign, the unary operator negates its value. Till now, we have seen all the operations are performed between the two operands, but this unary operator, by the name itself, we can say only takes single operand. So here b equal to 10. So we did a equal to minus of b. Okay, let's try this. A equal to 10, b equal to minus of a. So this is about unary operator, and the next one is bitwise operator. The operators are bitwise and bitwise or bitwise or bitwise not. So this is also similar to the logical operators, but the main difference is in logical operators we have used true or false. So the operands will form a result of either true or false. Ultimately, the operands will be in the form of true or false. But in the bitwise operators, the operands will be in the form of bits. So bits means zeros and ones. So here, what happens was the true will become 1 and the false will become 0. That's it. In bitwise and both the operands should be true. So that's why it was 1. A and B, first one is 1. And here B is 0. That's why the output was 0. A is 0. That's why output was 0. Both are 0. The output was 0. A or B, any one of the operand is true. So it is 1, 1, 1. Here both the operands are 0. That's why it was 0. The next one is bitwise XOR. XOR means exclusive OR. The functionality of XOR is if both the operands are same, then the output will be 0. If both the operands are same, then the output will be 0. Here A and B are same. That's why the output is 0. And A and B are different. The output is 1. A and B are different. The output is 1. Both are same. The output is 0. We have a formula for XOR that was AB bar plus B A bar. Bar means the not symbol. B bar, A bar means not B, not A. So let us take A equal to 1 and B equal to 1 only. So A 1, B bar means 0 plus 0 into 1. So that's why it was 0. Let us take this 1 and 0. 1 B bar means 1, 1 into 1 plus B 0 into A bar means 0 equal to 1 plus 0, that was 1. That's why the output is 1. So this is a formula for XOR, exclusive OR. And next one is bitwise NOT. If it will be 1, then output will be 0. If it was 0, the output will be 1. So 1, 0, 1, 1. Sorry, I need to change it. It will be 0 and this was 1. Yeah. So this is about bitwise operators. There is only single difference. That was instead of true or false, we will use zeros and ones. And the next one is membership operators. In Python, we have two types of membership operators. First one is in and second one is not in. These operators are suggest test for membership in a sequence, such as strings, lists, or tuples. In operator, the operator returns true if a variable is found in a specified sequence and false otherwise. So I want to find out whether the 20 is a member of this list or not, the sequence or not. Then this membership operators will be used. Let us say, let me write a code for it, then you will understand. I have a list which contains a numbers 20, 30, 40. Now I want to find out whether the 20 is a member of this list or not. If 20 in list, then print present. Or else print not present. Now let's run this program. The output is present. See, the 20 is present in this list. That's why this condition was executed and it was printed present. Let us say I want to check whether 50 is present in the list or not. Okay. So it was not present. Not present. 50 is not in the list. It was not belongs to that sequence. That's why it was printed not present. Next one is not in operator. The operator returns true if a variable is not found in a specified sequence and false otherwise, or else it will give you false. See, if 50 not in list, print not present. Or else print present. So yes, 50 is not present in list, so it needs to print not present. Yes, 40. Let's try 40. See, 40 is present. That's why it has given me present. Okay. And the next one is identity operators. Python has two identity operators. They are is and is not. These operators compare the memory locations of two objects. Let us say first one is is operator. Returns true if operands or values on both sides of the operator point to the same object and false otherwise. Let us say x equal to 1. So in Python, if we want to know the data type of the variable, then we'll use type of that variable name. So then it will give which type that it was belongs to. So if you see, let us say this x equal to 1, right? So it is an integer. So if you do type of x, then it will gives me int. If int is int, this condition is the left operand and the right operator denotes to the same object location. That's why this if condition will execute and it will print true, or else it will print false. So and then is not operator returns true if operands or values on both sides of the operator does not point to the same object and false otherwise. Let us say I will keep a string instead of this one. Let me keep x equal to a character. Then if you do type of x, then it will gives me a string. A string isn't no, and string is not int. Yes, it was true. I have a variable x equal to 1 to 3 and I want to find out type of x. Then it will give me class int. So the x will belongs to the integer class, int class, and x equal to ABC type of x. It's a string class and x equal to 1.2 type of x. It's a float class. Now let's execute a program. See, I have a variable x equal to 10 and y equal to the string was some ABCD. If type of x is int, print yes, or else print no. Let me run this. The output will be yes, right? So if you see, the output was yes. And let me do type of y is int. The output will be now false. Yeah, it was given me no. Yeah, the output was no. Now let's use is not operator and let's run. The output will be yes. Yeah, it given me yes. So the type of y, nothing but the string, is not int, and the type of x is not int. Then the output will be now no. Now the output will be no. Yes, the output was no. Okay. So this is about identity operators. Hey folks, if you enjoyed this coding tutorial and found it helpful, don't forget to give it a thumbs up. Share it with your fellow coding buddies, drop a comment with your thoughts or questions, and of course, hit that subscribe button and ring the notification bell so you never miss out on our latest content. Your support means a lot and it helps our community grow. Happy coding!